Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am an associate professor, Department of Computer Science, Hyderabad College, University of Delhi. So presently we are studying our subject on advanced data structures and algorithms, and within this series what we are going through presently is about the standard template library, or more specifically we can say iterators, and within the iterators we have started with the topic of vectors. So from last 2-3 lectures we have we are covering this topic vectors, and in our last lecture we have covered some basic operations like how to assign the how to assign elements to the vector, or how are we going to sort the vectors, how are we going to check whether they are whether a vector is empty or not, and all more basic operations we have covered. Continuing on the agenda, today's agenda is also about the operations on vectors, because being a part of a standard template library, there are so many functions which are available, and they handles day to day tasks which are to be done on the vectors so efficiently that it is necessary for a course or for a topic to be comprehensive. So it is necessary for a topic to cover them in order to be comprehensive. So let us move on with more operations on vector. In our previous lecture we have seen how to sort a particular vector, basically how to sort elements of a particular vector, but by default the elements of a particular vector are being sorted in the ascending order. Now a very common requirement along with this, which complements this scenario, is sorting in descending order also. So we will be having some ways of sorting in descending order. As we have multiple ways of sorting in ascending order, we will be having multiple ways of sorting in descending order also. Let us try to learn them one by one. So as I have told you, there are many ways, multiple ways. The simplest one is to sort the vector in a descending order is by using the sort function with a custom comparator. What kind of comparator I am talking about, that I am going to show you in a minute. So basically the sort is the function which is going to sort the vector by default in an ascending order. If you want the elements to be arranged in the descending order, you need to specify it using a custom comparator, and custom comparator is nothing but it is named as greater, and the sign of greater than and less than is going to be included as a parameter as it is shown on the screen. So we have a vector v which is obviously of integers, as the elements are there as 6, 8, 2, 9, and if we want to sort this vector in an descending order, we will write sort v dot begin to v dot end, and this v dot begin to v dot end we have also kind of seen in the last lecture, in the previous lecture. But here, as we want it to be sorted in the descending order, we want to pass a custom comparator as one of the parameters of the sort method. So the custom comparator will be written as greater, and then there is a sign of less than, then there is a sign of greater than, and then there is a sign of parenthesis, because this is a comparator. So the whole function syntax or the function prototype goes like this: sort within the bracket or as parameters it will be v dot begin, v dot end separated by commas because they are separate parameters, then greater, less than and greater than, followed by parenthesis and then parenthesis close. So this is going to be the syntax if we want our elements to be sorted in descending order. So this is one way. Let us look at other ways also. So using the simple sort function was one way to sort the vector in ascending order. Now if we want to make it to make the elements in descending order, one thing which we can do is we use the sort function in a simple way without the custom comparator, and then we will operate this then we will apply the function reverse on this on the v which is being sorted in the ascending order. So here we have one vector, again the similar vector I have taken, which is 6, 8, 2, 9, and in order to sort the vector, obviously in ascending order, I have given sort v dot begin to v dot end, and after sorting I am going to reverse this vector. So, in order to reverse the vector, I will be passing v dot begin and v dot end limits as parameter inside the reverse function. So, the first statement which says sort v dot begin to v dot end will sort the elements normally, and then what are we going to do is to reverse the element, and then finally when will you print the contents of the vector v, this is going to be you will have the elements sorted in the reverse order. So, two ways we have seen. One is using sort with a custom comparator, another one is kind of using the reverse function after the normal sort function. Now, please remember our previous lecture in which we have used the function stable sort, which is written as stable underscore sort, and stable underscore sort is the function which is going to preserve the relative order of non-unique elements, or it is going to preserve the relative order of the elements which are we can say which are equal. So, we can use stable sort v dot begin v dot end, this we have already used, but here in order to make the result in descending order, we are going to use the custom comparator, which is greater and greater than sign and less than sign, and then there is a greater than sign followed by a parenthesis. So, instead of normal sort, if we want our sorting procedure to be stable in nature, we can use stable sort also. This is also a way of descending arranging the elements of vector in a descending order. Moving forward from here, we want to now this is a very common requirement that we want to copy a particular vector into another vector. So, there are again different ways of copying a vector in C++ to another vector. Let us explore them one by one. These are very simple and I can say very obvious ways of vector copying. So, here is a vector v1 which is having elements 2, 4, 1, 5, 3, and if we want to assign the elements of vector v1 into the vector v2, we need to declare this vector v2, which is being done by vector int v2, and then maybe in the similar line or maybe in the next line we can write v2 is equals to v1. So, what is going to be done here, all the elements of v1 will be stored inside the v2, and then we have created a copy of the vector v1 and the new copy is the vector v2. So, the contents of v1 will remain as it is and the v2 will be created as one of the copies of v1. So, that is one thing. Then you remember your basic C++, we have lots of constructor. If we want to copy one contents of one object into another, we can do it through the constructor also. So, here also we can use vector constructor, which is another easy way to copy a vector into another. But this is going to be done at the time of declaration, and because we are using the constructor here, and this is done by passing the original vector to the copy constructor of another vector. So, for example, we have vector int v1 is equals to 2, 4, 1, 5, 3, the the old vector we have taken as an example. And if we want to copy this v1 into v2, so wherever we are going to declare this v2, within the constructor of v2 we are going to pass v1 as the parameter as it is shown here. So, we have vector int v2 and within the bracket v1. So, whatever contents of v1 are there, will be copied into the vector v2 at the time of initial or at the time of declaration only. So, whenever your v2 is going to be declared, it will be created, and it will be created with the elements of v1. So, that is also kind of one of the possibility if we want to copy the vector. So, one idea is the kind of, we can say, assignment operator, which we have just seen, and the second idea is, which we were just exploring now, is using the constructor of the vector at the time of declaration. So, two ways of copying the vector we have seen. Then another idea, or another way of copying the vector elements of one vector into another is basically equivalent, or this method is equivalent to the assignment operator, which is the is equals to operator, but it needs the iterator to the vector to be copied. So, iterator which is available, iterator to the vector which is available as a part of vector, that that will be copied. So, here we can see we have a vector v1 with the same elements 2, 4, 1, 5, 3, and we have declared one more vector which is nothing but v2. Now, what do we want to do is copy all the elements of v1 into v2. So, we have v2 dot assign from v1 dot begin to v1 dot end. So, this iterator to the vector is going to be copied, because in the as the parameters of assign, we have given that whatever is to be assigned into v2 is nothing but iterator values starting from v1 dot begin to v1 dot end. So, whatever contents are there starting from v1 dot begin to v1 dot end will be assigned to v2 also. So, this is also a method of we can say copying. So, we have seen three methods. One is the assignment operator, which is equals to, then we have seen constructor, and then we have seen the method assign. Moving forward, the fourth way of copying the vector is the method vector insert. Whatever is to be insert into the vector, those values we are going to give as the parameters, and this insertion will start from which particular point or which iterator value in the new in the new vector, that also has to be seen. Let us see this with the help of an example. So, this vector insert method provides a version which is going to copy all the elements from a given range. So, this range could be whole of the V, or it could be using some indexes inside the V or something of that sort. Now, this can be used to copy the entire vector to another in a similar way as we do it in a normal assign method. So, here we have a vector v1 which is having some elements, and then a new vector v2 is kind of being declared. In order to copy the elements of vector v1 into v2, we are going to use v2 dot insert, and within the bracket we have passed three parameters: v2 dot begin, v1 dot begin, v1 dot end. So, the first parameter, which is v2 dot begin, says this is actually the position from where to where actually the copying is going to start, and v1 dot begin to v1 dot end is the range which is to be copied. So, here these three parameters says that there is a range starting from v1 dot begin to v1 dot end, which is the parameter number 2 and parameter number 3. So, this range is to be inserted into v2 from the pointer or from the iterator, we can say, which is nothing but v2 dot begin. So, if we want to kind of copy the elements not in the first two locations, we can set v2 dot begin plus 2 or something of that sort, but here we have written v2 dot insert within the bracket v2 dot begin comma v1 dot begin comma v1 dot end. So, starting from v1 dot begin to v1 dot end, all the elements will be copied into all the elements will be inserted into V2 starting from the position V2 dot begin. So, that is one idea. So, 4 ideas of copying the vector we have seen. One more very interesting idea is you take the elements from one particular vector and push them back into another vector, and push back is the function which we have seen in our last lecture, that this is going to insert elements at the back of the or at the end index of the vector one by one. So, here this all the elements of the first vector will be pushed into the second vector, and here we are going to use the method push underscore back, and because this is kind of working with one particular element at a time, we need to use a loop that can iterate through the kind of source vector from which we want to copy the values. So, our source vector here is V1, and then we have our destination vector which is V2, and then within the loop as you can see for auto I goes for V1 which is colon V1, we need to say V2 dot push underscore back I. So, what this function is going to do for all the kind of elements I elements of vector V1, it will pick the element one by one, and then after picking it is going to push back the elements into kind of the new destination vector which is nothing but V2. So, now if we talk about copying the vector, we have seen 5 different ways of copying the vector. One is using the is equals to, which is nothing but the assignment operator. Then we have used vector constructor, which is being used at the time of declaration mostly. Then we have used vector dot assign method. Whatever values are to be assigned, those are to be kind of passed into the parameters. Then we have vector insert. So, vector insert is the method in which we need to give the range which is to be inserted and also the position at which it is to be inserted. Then if we want to do it one by one, we can we can code a loop or we can implement a loop there, take the elements one by one and then push back in all those elements into the new vector which is going to be the destination vector. So, pushback is another, or we can say the 5th method. Now, moving forward to the next task of vector swapping. So, we have so many built-in functions which are used to exchange the contents of 2 vectors of the same type. Now, please be clear here that this swap which I am talking about, it is not going to copy, move or swap the individual elements. In the previous lecture, whatever we have seen about swap was moving or swapping the elements, individual elements internally. This swap is not going to do any task of such type. Instead, it swaps the internal pointer to the dynamically allocated array of both the vectors. So, here we will be having 2 vectors and then we will be swapping the values of these 2 vectors. So, this is not within the one vector in which you are going to take 2 values which is the first and last, maybe second last and the the second value and then swap. No, nothing of that sort. 2 dynamically allocated arrays, or more specifically 2 vectors we will be taking, and these 2 vectors will swap their elements. Now, the question comes up about the size. Size will be updated for both the vectors, size will be updated accordingly. So, here in order to use this version of swap, we are going to 2 vectors as it is shown on the screen. We have V1 which is 1, 2, 3 and V2 which is 10, 20, 30. You can print the contents before swapping, and here when we want to swap vector 1 and vector 2, we are going to write V1 dot swap V2, and then contents of the two elements can be printed again in order to see the effects of v1 dot swap within the bracket v2. So, one is the vector v1 which is calling this swap function, another one is the vector v2 which is being passed as an argument to this swap function. So, the calling vector and the argument vector will swap their kind of contents, we can say. Now, please notice that this is different from the swap which we used in our previous lecture, which was swapping the elements in between. Now, this is only one more example of swapping the contents of the two vectors could be based on the string. So, it is not kind of not necessary that there are only integers, or maybe you can say numbers. We can have strings also. So, here as it is shown on the screen, we have two vectors. One is v1 which is having 3 strings apple, banana and cherry, and another one is a vector which is v2 and having 2 values orange and kiwi. And when we want to swap these two, so we will write v1 dot swap within the bracket v2. So, contents of v2 now after this swap will be apple, banana and cherry, and contents of v1 will be orange and kiwi. So, that means the contents are basically we can say swapped. Whatever type of data this is, whether this is integer or whether this is a string, it is okay for a vector to be used in this way, because these are kind of generic types, we can say. Now, there are certain situations in which we actually want to find out something unique. That means we actually want to remove the duplicates from a vector. Now, in order to remove the duplicates from the vector is first let us arrange the elements of vector in a particular order, and then we will use kind of the function unique, or we can kind of, and we can then remove them using the vector erase. So, how these functions can be used in order to remove the duplicates from a vector, that is, let us see. So, we have a vector which is having multiple values. We have 2 times the digit 2 is occurring, then we have 5 which is also occurring 2 times, then we have 4 which is also occurring 2 times. And what do we need to do? We need to remove all the duplicate elements. So, for this, the first step is we are going to sort starting from v dot begin to v dot end, and I hope that you are clear with this particular syntax now, that what it is going to be done. Then, in order to move all the duplicates to the last of vector, we are going to start a variable or declare a variable it, which is of type auto, and I am sure you understand this. Then we have unique v dot begin to v dot end. So, whatever elements are duplicate will be kind of we can say will be shifted to the position it, and if we want to remove all these duplicates, we will be using v dot erase. It is the position. So, starting from it to v dot end, we want to erase all the elements, and the syntax of erase we have seen in the detail in our previous lectures. So, in order to remove all the duplicates, we are going to use sorting. Then we will be uniquely placing them, or we will be placing the duplicate members at the end of the vector, and then we will be removing all those duplicates which are placed in the end of the vector by using v dot erase. So, unique function here will move the duplicate elements to the end of the vector, and it is going to return an position, or we can say an iterator to this kind of to that position or to the new logical end. Why are we saying it as a logical end? Because the unique elements are kind of completed by that position, but it need a sorted range. The first kind of important thing here is that your unique function needs a sorted range. So, we need to sort the array first and then we will pass it on to the unique. If we are going to pass it on to the unique, which is an array non-sorted, it is not going to work the way we want to do it. Then finally, the duplicates are removed using the vector erase method. Now, there are some other methods which are there in order to remove the duplicates. I will be covering all those other methods in my next lecture, and we will be moving towards the completion of all other vector methods. That is all from my side for this particular lecture. Here is a list of references which is being used for preparation of this. I hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.